Hello students, welcome to our YouTube channel Experience Tutor. Today we'll discuss class 11th physics, laws of motion, chapter 5, NCERT solution, part 2. Our mission is to provide free classes on YouTube for all the students of class 6 to class 12, special classes for the student preparing for IIT, JEE, NET, NDA and other competitive examinations. Before we start, we request you to subscribe, like, and share our channel. Please click on the subscribe button to support us and also click on the bell icon to get automatic notification whenever a new video is uploaded by us. Let us begin our course. In the last session, we have done till uh, 5.10 exercise questions from NCERT. Today we'll start with 5.11. The question is, a truck starts from rest and accelerates uniformly at 2 meters per second square. At t is equal to 10 seconds, a stone is dropped by a person standing on the top of the truck, 6 meters high from the ground. What are the A. velocity and B. acceleration of the stone at time t is equal to 11 seconds? Neglect air resistance. So here part A, 22.36 meter per second is the velocity at an angle 26.7 26.57 degrees centigrade with the motion of the truck. But this is only the answer. We'll show you how we have solved it. So initial start from this line. Initial velocity of the truck u is equal to 0. Acceleration is equal to a is equal to 2 meter per second square. Time 10 seconds. As per the first equation of motion, final velocity is given by v is equal to u plus at, this formula. So we can say put the values of u and t, will get 20 meter per second. Now the final velocity of the truck and hence of the stone is 20 meter per second. At t is equal to 11 second, the horizontal component Vx of velocity in the absence of air resistance remains the unchanged, that is Vx is equal to 20 meter per second. The vertical component Vy of the velocity of the stone is given by the first equation of motion as Vyu plus a y dt, where dt change in time is equal to 11 minus 10, that is 1 second. Ay is equal to g, which is acceleration due to gravity, that is 10 meter per second square. Vy is equal to 0 plus at or gt, that is 10 into t, that is 10 meter per second. The resistance of the resultant velocity of the stone is given by. So we know the resultant velocity v is equal to vx square plus uh, vy square under root. So put the value of vx and vy 20 and 10, then 400 and 100, that is 500 root and so root 500 upon solving we get 22.36 meter per second. Let theta be the angle made, this angle theta, by the resultant velocity with the horizontal component of velocity, that is Vx. So tan theta is equal to Vy by Vx, theta is equal to tan inverse 10 upon 20. Now upon solving we'll get tan inverse zero point 0.5, whose value is 26.57. When the stone is dropped from the truck, the horizontal force acting on it becomes zero. However, the stone continues to move under influence of gravity. Hence, the acceleration of the stone is 10 meter per second square at and it acts vertically downward. So this is the complete answer for question number 11. Let us move to the next question. The next question is 5.12. A bob of mass zero point 0.1 kg hung from the ceiling of a room by a string 2 meter long is set into oscillation. The speed of the bob at its mean position is 1 meter per second. What is the trajectory of the bob if the string is cut when the bob is A at one of its extreme position, B at its mean position? So for the solution of 5.12, let us see how to solve 5.12. So here part A, vertically downward and parabolic path is the answer. So how, the explanation is, at the extreme position the velocity of the bob becomes zero. So at extreme position the velocity will become zero. If the string is cut at this moment, the bob will fall vertically on the ground. Now part B. At the mean position, the velocity of the bob is 1 meter per second at the mean position. The direction of this velocity is tangential to the arc formed by oscillating bobs. So tangential to the arc. If the bob is cut at the mean position, then it will trace a projectile path having the horizontal component of velocity only, hence it will follow a parabolic path. So this is the answer, explanation to the answer. Let us move to the next question. Question number 5.13. A man of mass 70 kg stands on a weighing scale in a lift which is moving A upward with a uniform speed of 10 meter per second, B downward with a uniform acceleration of 5 meter per second square, C upward with a uniform acceleration of 5 meter per second square. What would be the reading on the scale in each case? D, what would be the reading in if the lift mechanism failed and it hurtled down freely under gravity? So let us see what is the solution. So mass of the man m is equal to 70 kg. Acceleration A is equal to 0. Using Newton's second law of motion, we can write that equation, that equation of motion as R minus mg is equal to ma, where ma is the net force acting on the man as the lift is moving with a uniform speed of acceleration 0. Since acceleration A is equal to 0, then R is equal to mg. Putting the value of m and g, we get 700 Newton. 700 Newton. Oh, yeah. So we get 700 Newton. Reading on the weighing scale is equal to 700 upon g, that is 700 upon 10, that is 10 kg. Mass of the man m is equal to 70 kg. Acceleration A is equal to 5 meter per second square downward. Using the Newton's second law of motion, R plus mg is equal to ma. M is common, then m common a minus g. Putting the value of m, a and g, we get 70. 10 minus 5, that is 70 into 5, that is 350 Newton. Now, therefore, reading on the weighing scale 350 upon g, which is equal to 350 by 10, that is 35 kg. Mass of the man m is equal to 70 kg. Acceleration A is equal to 5 meter per second square upward. Using the Newton's second law of motion, we can write equation of motion as R minus mg is equal to ma. R is equal to m common g plus a. Putting the value of m, g and a, we get 75 plus 10 plus 5, that is 15. 17 to 15, that is 1050 Newton. So reading on the weighing scale is equal to 1050 upon g, that is 1050 upon 10, that is 105 kg. When the lift moves freely under gravity, acceleration A is equal to z. Using Newton's second law of motion, we can write the equation of motion as R plus mg is equal to ma. R is equal to m g minus a, and instead of a, we'll put g, that is m g minus g, which is therefore R is equal to 0 in this case. Reading of the weighing scale is equal to 0 upon z, that is 0 kg. So in this case, reading will be 0 kg. The man will be in a state of weightlessness. So this is the end of this sum. Now let us move to the next sum. Now we'll do question number 5.14. Figure 5.16 shows the position time graph of a particle of mass 4 kg. What is the A force of the particle on for t is less than 0, comma t is greater than 4 seconds, comma t is greater than 0 and less than 4 seconds. B impulse at time t is equal to 0 and t is equal to 4 seconds. Consider one dimensional motion only. So we can see the figure here will use the concept of Newton's law of motions, and we'll solve this. Let us move to the solution. So first we'll solve part A. For t is less than 0. It can be observed from the given graph that the position of the particle is coincident with time axis. If it indicates that the displacement of the particle in this time interval is 0. Hence, the force acting on the particle is 0 for t is greater than 4 seconds. It can be observed from the given graph that the position of the particle is parallel to the time axis. So, it is parallel to the time axis. It indicates that the particle is at rest at a distance of 3 meters from the origin. No force is acting on the particle for 0, t is less than 0 and greater than t is greater than 0 and less than 4. It can be observed that the given position time graph has a constant slope, hence the acceleration produced in the particle is 0. Therefore, the force acting on the particle is 0. At t is equal to 0, impulse is equal to change in momentum, that is mv minus mu. Mass of the particle m is equal to 4 kg. Initial velocity of the particle u is equal to 0. V is equal to 4 by 3 m meter per second. Final velocity of the particle, that is 4 bracket 3 by 4 minus 0, is equal to 3 kg meter per second. Impulse is equal to at impulse at time t is equal to 4 second. Initial velocity of the particle u is equal to 3 by 4 meter per second. Final velocity of the particle v is equal to 0. Impulse is equal to 4 bracket 0 minus 3 by 4, that is minus 3 kg meter per second. So let us see the next problem, that is 5.15. Two bodies of mass 10 kg and 20 kg respectively kept on a smooth horizontal surface are tied to the end of the light string. A horizontal force F is equal to 600 Newton is applied to one A to B along the direction of the string. What is the tension in the string in each case? Horizontal force F is equal to 600 Newton. Mass of the body A m1 is equal to 10 kg. Mass of the body B m2 is equal to 20 kg. Total mass of the system m is equal to m1 plus m2, that is 30 kg. Using Newton's second law of motion, the exertion A produced in the system can be calculated as F is equal to ma. A is equal to F by m. So putting the value of F and m, we get 600 upon 300, that is 20 meter per second square is the acceleration. When F is applied to body A, the equation of the motion can be written as F minus t is equal to m1a, t is equal to F minus m1a. Putting the value of F, m1 and a, we get 600 minus 10 into a 20, that is 400 Newton. This is the first equation. When the force is applied in body B. So when a force is applied to body B, this is the diagram, then we can say the equation of motion can be written as F minus T is equal to M2A. T is equal to F minus M2A. And putting the value of F, M2 and A, we get 600 minus 20 into 20, that is 600 minus 400, that is 200 Newton. This is equation 2, and this is the solution also. Let us move to the next question. Now we'll move to question number 5.16. Two masses 8 kg and 12 kg are connected to at a to, at the two ends of of a light inextensible string that goes over a frictionless pulley. Find the acceleration of the masses and the tension in the string when the masses are released. So the solution is the given system of two masses and a pulley can be separated as given below. So here we can see mass 8 kg and 12 kg are hanging by a pulley where tension is acting upward. Here tension is acting upward, acceleration is acting downward. Here acceleration is acting upward, the body is moving upward, this 8 kg mass is moving upward. So smaller mass m1 is equal to 8 kg, larger mass m2 is equal to 12 kg. Tension in the string T, mass m2 owing its weight moves downward with acceleration a, and mass m1 moves upward. So applying Newton's law of motion to the system, each mass for mass m1, the equation of the motion can be written as T minus m1g, that is ma, equation number 1. For mass m2, the equation of the motion can be written as m2g minus t, that is m2a, which is equation 2. Adding equation 1 and 2, we get m2 minus m1 g is equal to m1 minus m2, m1 plus m2 a. A is equal to m1 minus m2 upon m1 plus m2 g, that is equation number 3, is equal to 12 minus 8 upon 12 plus 8 into 10. Upon solving, we get 4 upon 20 into 10, that is 4 meter per second square. Therefore, the acceleration of the mass is 2 meter per second square. Substituting the value of A in equation 2, we get m1g minus t is equal to m1 bracket m2 minus m1 upon m1 plus m2 g. Now t is equal to m2 minus m2 square minus m1 m2 upon m1 plus m2 is equal to 2 m1 m2 upon m1 plus m2 g. Putting the values of m1 m2 and g, we get 2 into 12 into 8, 12 plus 8, that is 2 into 12 into 8 up on 20 into 10, that is 96 Newton. Therefore, the tension in the string is 96 Newton. This is the answer. Let us move to the next sum. Now let us do 5.17. A nucleus is at rest in the laboratory frame of reference. Show that if it disintegrates into two smaller nuclei, the products must move in opposite direction. So let M1, M, M1 and M2 be the respective masses of parent nuclei and two daughter nuclei. The parent nuclei is at rest. Initial momentum of the system parent nuclei is equal to 0. Let v1 and v2 be the respective velocities of the daughter nuclei having masses m1 and m2. Total linear momentum of the system after disintegration is equal to m1 v1 plus m2 v2. According to the laws of conservation of momentum, total initial momentum is equal to total final momentum. So total initial momentum was 0 is equal to m1 v1 plus m2 v2. So So we can write P1 is equal to minus M2 V2 upon M1. Hence, the negative sign indicates that the fragments of the parent nuclei move in the direction opposite to each other. Let us see the next problem. So let us see 5.18. Two billiard balls, each of mass 0.05 kg, moving in opposite direction with speed 6 meter per second, collide and rebound with the same speed. What is the impulse imparted to each ball due to other? Let us see the solution. So mass of each ball is equal to 0.05 kg. Initial velocity of each ball 6 is equal to 6 meter per second. Magnitude of initial momentum of each ball P1 is equal to zero point 0.3 kg meter per second. After collision, the ball changes their direction of motion without changing the magnitude of their velocity. Final momentum of each ball Pf is equal to minus zero point 0.3 kg meter per second. Impulse imparted to each ball is equal to change in momentum of the system, that is Pf minus Pi, that is final momentum minus initial momentum. So putting the value of Pf and Pi, we get minus zero point 0.3 minus zero point 0.3, that is zero point 0.6 minus, here it will be minus uh, zero point 0.6 kg meter per second. The negative sign indicates that the impulse imparted to the ball are opposite in direction. Let us see the next sum. Now let us do 5.19. A cell of mass 0.020 kg is fired by a gun of mass 100 kg. If the muzzle speed of cell is 80 meter per second, what is the recoil speed of the gun? Let us see the solution. Mass of the gun is capital M is equal to 100 kg. Mass of the cell is small m is equal to 0.020 kg. Muzzle speed of the cell is equal to V is equal to 80 meter per second. Recoil, recoil speed of the gun V is equal to capital P. Both the gun and cell are at rest initially. Initial momentum of the system is equal to 0. Final momentum of the system is equal to small m small b minus capital M capital P. Here the negative sign indicates appears because the direction of the cell and the guns are opposite to each other. Here the negative sign appears because the direction of the cell and gun are opposite to each other. So according to the law of conservation of momentum, mv minus mv is equal to 0, v is equal to mv upon capital M, that is putting the value of small m, small b and capital M 0.020 into 80 upon 100 into 1000 is equal to 0.016 meter per second. And this is the answer. Now let us see the next sum. So a batsman 5.20, a batsman deflects a ball by an angle of 45 degree without changing the initial speed. What is what is equal to 54 kilometer per hour? What is the impulse imparted by the ball? Mass of the ball is 0.15 kg. So mass of the ball is 0.15 kg. Let us see the solution. So the given situation can be represented as shown in the figure, where AO is equal to initial path of the ball, this AO, and OB, path followed by the ball after deflection. Angle AOB is equal to angle between the incident and deflected path of the ball, that is 45 degree. Angle AOP is equal to angle BOP, that is equal to 22.5 degree, is equal to theta. So initial and final velocity of the ball is equal to v. Horizontal component of the initial velocity is equal to v cos theta along RO. Vertical component of the initial velocity is equal to v sin theta along PO. Horizontal component of the final velocity v cos theta along OS. Vertical component of the final velocity is equal to v sin theta along OP. The horizontal component of the velocity suffers no change. The vertical component of the velocity are in opposite direction. Impulse imparted to the ball is equal to change in linear momentum of the ball. Therefore, we can write mv cos theta minus mv cos theta, that is 2 mv cos theta. Mass of the ball is equal to 0.15 kg. Velocity of the ball v is equal to 54 km per hour, that is 15 meter per second. Impulse is equal to 2 into 0.15 into 15 cos 22 and half degree. Upon solving, we get 4.16 kilogram meter per second. And this is the end of today's class. In the next class, we'll continue with the rest of the sums. Before we end it, please subscribe, like, and share our channel. Please click on the bell icon to get automatic notification whenever a new video is uploaded by us. And also click on the subscribe button to support us. Thank you for your help and watching our videos. Write a comment uh, in the comment box about your feeling, about how you like the video or what you need more. Will reply you as soon as possible. Thank you very much.